All right, good afternoon, everybody. Welcome to technical session number 5, entitled Data and Artificial Intelligence in Action, Balancing Innovation and Safety. My name is Basha Saul. I'm the NRC Chief Data Officer and the Director of Data Information Management and Enterprise Governance Division. I'm really excited to be here this afternoon to talk with you. We've got a great panel set up and some wonderful presentations. We look forward to also hearing some of your questions, so please, if you haven't had a chance yet to scan this, please go ahead and scan so you can enter in questions. Our great folks over here, Taylor and Isaac, are going to be taking a look at this and helping us star and get those questions over to us as well. So I do want to give first a thank you to Taylor Lamb, who is our coordinator for today's session. She's done a great job getting us all prepared and ready to talk to you all. Thank you. So I'm going to start by just introducing the panel and then providing some opening remarks, and then after that we'll get into the presentations. So first I have Jason Carneal here. He's from NRC. He's been over in OCIO helping us with all things data, and is back in NRR as a senior engineer. Wait, do I have that right? Well, I have senior data scientist, so I'm going to go with that, Jason. Matt Homiak, Reactor Systems Engineer over in our Office of Research. Thank you, Matt. We also have Kelly Volsing. She's from NEI, and she is the Director of Engineering. We have Tom Gruenwald. He is from Blue Wave. He's Executive Vice President. And then finishing up, we have Scott Seidner, Chief Engineer, Digital and Data and Artificial Intelligence at Westinghouse Electric Company. So we look forward to hearing all of the presentations today. All right. So really excited to talk with you all. About a year ago, we had a similar presentation. We were just getting ready to take a look at how we would apply artificial intelligence at the NRC for some of our internal processes. We had been working on a strategic plan that worked externally and working with our stakeholders, and then we were tasked by our chair to take a look internally how we could start applying that. And it was a really great process. We worked across the agency, and I had a great team. I partnered with Vic Hall as my co-executive sponsor for that project. And we had a great team of Taylor Lamb, Bob Randall, Luis Betancourt, make sure I know Matt Dennis, Tyson Campbell. And that team was able to create a paper that outlined our plans for how we would apply artificial intelligence at the NRC. You can find that online at nrc.gov/AI, along with other activities that we're currently undertaking. Some other things I want to highlight that's happened in the past year. We released Adams Public Search. Many of you have questions about how to get data out of Adams Public Search. We had a new search. It was similar to something we had created on cognitive search internally. And so anyone who's used that, we're getting great feedback. We just had an Adams user group give us wonderful feedback saying how much this has changed the way that they search data from the NRC. We, over the summer, had a series of discussions with our external stakeholders about how they need to access data. We really are focused on data democratization at the NRC, and that's really getting data into the hands of folks, both internally and externally, that are public facing, so that they can start using that to help with their AI journeys as well. We've been leveraging the data lifecycle to ensure that we have access to information from beginning to end, and really taking a look at what information means and how we turn that into usable data. I also want to note that in June of last year, we ended up the federal government wrapping up having paper records. I want to give a round of applause for that. So that solidified us into the digital era. And that means that data now becomes the way that we are moving and using our information at our agency. Data is just, is information. And when we integrate it with artificial intelligence, it transforms it into a powerful way to discover and be efficient and help us with decision making. A couple of data points I want to share. 90% of the world's data has been generated in just the last 2 years. Over 80% of our enterprise data is unstructured, and it makes AI even more important to be able to help us unlock that value. Poor data quality costs organizations about 15 to 25% of their revenue every year. And in the global look, we are creating data in just unprecedented amounts. And so really, we have to find ways that we can leverage that to make us more efficient and effective. So there's an opportunity to harness the power of AI. We're really looking forward to finding ways that we can find ways that we improve our regulatory capabilities. And we're going to discuss that today. I'm really looking forward to hearing from these presentations. And I encourage you to think about this. The value of data is only as good as the questions we ask it. So let's go ahead and take a look at those boundaries and push them, and let's see what the possibilities are of the human expertise with AI intelligence. So let me go ahead and dive in and start with Jason and Matt are going to do a co-presentation, but we'll start with Jason. Thank you.
All right, good afternoon, everyone. It's a little bit like Close Encounters of the Third Kind in here. But Matt and I are going to talk about putting data to work at NRC and describe some of the initiatives we have with regard to data and artificial intelligence that are coming down the pike at NRC. Next slide, please. So I'd like to highlight our data priorities for 2025 first. First, we're looking at data collaboration throughout the organization. What we've had over the last couple of years is kind of centers of expertise popping up across the agency and various offices. So we have experts in data that might be scattered across the organization and in kind of stovepiped areas. So we're hoping to break down the barriers between those experts, have our shared knowledge, allow us to leverage shared knowledge and expertise, and bring together those perspectives across the agency. That would also allow us to quickly respond to some of the AI initiatives that are coming down the line and evaluate those in a timely manner. Our second focus is on data democratization. As Aja mentioned, we're trying to leverage all the data that we have across the organization and lower the bar of access to that information for our internal experts and for members of the public and external stakeholders to foster informed decision-making and innovation. We're also updating our data governance procedures to help with some of the data quality issues that we've experienced in the past by having a more organized approach to maintenance and oversight of our data programs. For example, identifying clear data stewards for each data set that we have in the organization and providing tools to them that will allow them to monitor data quality and take corrective action where necessary. Next slide, please. So over the last couple of years, our primary focus on the data side has been consolidating data sets from multiple NRC systems into a centralized repository, which is, we call it the NRC Data Warehouse. And again, this allows users throughout the organization to sign up and access any of the data that we've added to the data warehouse, and allows us to construct specific views to address business use cases that we've received. So we can have one clear quality data set for a specific question that we can refer to. For example, if you go back a few years, when we were trying to trend findings data, for instance, if you asked 10 different people to track findings across the regions, you get 10 different answers. Now we have one centralized data set and a clear set of queries that you can use to get that information in seconds. I think that's all I had for that. Next slide, please. So in general, the NRC doesn't have big data. You're not looking at millions of lines of line entries here unless you're looking at time data. But we do have a lot of unstructured text data. So there's kind of two tracks here. We want to leverage the structured data we have and extract as much as we can from existing documents. And for the unstructured text data, there's probably a second track where we'll be using large language models and other available tools to leverage some of that information. This is kind of a combination example that I've put here on NRC Form 366, licensee event reports. We trained a model in Microsoft Document Intelligence to automatically extract the form information from this form and the abstract and the unstructured text that comes in with the rest of the report. So what this allows us to do is automate some previously manual downstream processes like data entry. It also provides us some information that was not previously available at NRC, like the component and system codes that we extracted. And it will also allow us to perform machine learning and natural language processing on the structured data and abstract text data. For example, we built a classifier that can categorize that information by technical review group, inspection procedure, those types of things. To specifically talk about some of the downstream processes, I'll hand it off to Matt to talk about where we're going from there. Thank you.
All right, thank you, Jason. Let's take a trip this afternoon. The trip we're going to go on is to look at the transformative power of NRC data and how we put NRC data to work. Good news is everyone in this session is invited and online too. Jason's gassed up the car. He's given me the keys. Basha, she's going to ride passenger, but the data scientist gets to drive. If we could go 2 slides ahead, please. Okay, yeah, thank you. So the first step of our journey is going to be to set the destination. And our destination is going to be the classification of licensee event reports using artificial intelligence. We'd like to identify events that have human performance issues, and we're exploring this as an active research project. Now, why licensee event reports? There's 5 components to NRC's regulatory program: regulations and guidance, licensing, oversight, support for decisions, and operating experience. Licensee event reports are a primary form of operating experience, so there's a direct tie between licensee event reports and how the NRC does business. Now, why human factors? This is from the data itself. From 2000 to 2017, nearly 40% of the LERs had some kind of human performance issue. And in the past, classification of LERs for human factors issues was done 100% by human intelligence. So with this project, we'd like to see if we can change that. Our goals for the project, first, are to fill data gaps. We'd like to take that human encoded information in our human factors information system. It only spans a certain period of time. We'd like to see if we can cover some of the earlier periods, and certainly to do that automatically going forward. Our second goal is to accelerate delivery of information. If we can encode these human factors issues in the LERs in real time, then we can get that information to our human factors staff that much faster. Third goal is to build knowledge in artificial intelligence applications by just doing the project, and this supports one of our goals from our NRC AA strategic plan. And if we could go back 2 slides, please. One more. There you go, thank you. Okay, so now we have our destination set for our journey. It's time to gather the supplies. And the supplies for our trip are going to be the data itself. For this project, it's going to be high-quality structured data right from our NRC data warehouse. That's going to include the licensee event report information, like Jason just mentioned. And it's also going to include information from our human factors information system, which is a separate data set. After we have the supplies, we need to plan the route. So our route here is the data pipeline, like it's shown on the slide. We'll start from the NRC data warehouse. We'll combine those data sets using SQL queries so we can get an optimized data set that will clean the text, doing some text transformation techniques, and basically get it ready for processing with artificial intelligence and machine learning technologies. Next slide, please. All right, so the only thing that's left is to hit the road. In our road trip analogy, the AI tools are the car, and they're going to take us where we want to go. LERs are textual information, so we'll be firmly in the natural language processing domain. We'll be using all open source models for this project. At the start of the trip, we may just need a car with a few features. Some simple machine learning models we'll try out first, see if we'll get the job done, but we may hit some unexpected detours or obstacles, bumps in the road, if you will. That might include missing data, unexpected results, or technical difficulties. In that case, we may need to upgrade our carve to one with more features. We may look at a large language model or even fine-tuning our own large language model. In the end, our goal is a high accuracy classification model for these licensee event reports with human factors information. Next slide, please. One more. There you go, thank you. Okay, so by putting NRC data to work, we're going to drive innovation and efficiency in our regulatory activities. We're going to meet the needs of our stakeholders and maintain our commitment to safety and excellence. If you are on your own data science or AI journey, we invite you to join our symposium that's going to be held this Thursday right after the RIC. You're welcome to join us if you have time. If you want to come up here and scan this QR code, nobody's going to complain. You can register using the QR code there, or we also have details up on our public website. One caveat, though, that I need to mention is that if you are a foreign national and you have not already submitted your passport information, you cannot attend the session in person, but you're still welcome to view it online with the hybrid virtual option. There we go. Thank you very much.
Adjust it for short people. All right, so thank you for the opportunity to be here. My name is Kelly Volsing. I'm with NEI. And let me start with a little disclaimer. I am not a data scientist or a computer science engineer, so I will deflect all difficult questions in that arena to Matt. I have more than 30 years, more decades than I'd like to admit, experience, mostly in engineering, licensing, and risk analysis in the nuclear industry. So I come at this presentation from that perspective as one of an enthusiastic end user that sees tremendous opportunity for our industry in the application of AI. And specifically, in the last couple of years, I'm talking about large language models. All right, so next slide, please. Okay. So first, we are nuclear engineers, so we like to dive deep into technical details and get into the weeds on things very quickly. So in a lot of industry meetings that I attend where AI comes up, we very quickly get into data protection and IP and cybersecurity and export control and all of the challenges associated with responsible, ethical, and highly validated uses of AI and the challenges that they present. And I by no means want to minimize the importance of those challenges. They are clearly important for an industry like ours, but I don't want us to lose sight of the tremendous opportunity that AI can provide for knowledge-based workers like us in our industry. Next slide. So first I'll start with just to say there are a lot of you in the room, and it is a gorgeous day outside, and I also have observed that I think AI has been mentioned in every session I've attended so far, so clearly there is strong interest. In terms of what we're hearing from licensees, vendors, stakeholders in the nuclear industry, there are dozens, if not hundreds, of use cases where people are finding value and seeing application for AI, but they are mostly, or almost all, of the near-term and medium-term cases associated with supporting and enhancing engineering and decision-making. So I would think of that as augmenting our work, not replacing humans in the loop. And so, some examples include, use of AI in the corrective action, screening and trending, maintenance activities, so monitoring for anomalies and optimizing maintenance based on big data, work management, development, and optimization, compliance and reporting, procurement optimization, when am I going to need parts in the warehouse, how many am I going to need, what kind of insights can I get from AI for that, operating experience efficiency, so finding the needle in the haystack, finding the operating experience that's relevant and useful and applicable to the situation you're searching for, and then training and knowledge transfer. Many of the sessions today have also mentioned the workforce challenges in our industry, a lot of new people coming in, and the need to get them trained and up to speed and contributing quickly, and I think AI has tremendous value and potential in that area as well. These are, I could talk about any of these use cases in the industry, but for the purposes of this presentation, being that we are at the Regulatory Information Conference, I thought I'd highlight a couple of potential applications or uses in the regulatory arena. So if you can go to the next slide. So first, accelerating knowledge management. Hypothetical case here, you're a new employee at the NRC and, you need to go out on an audit or an inspection team, or you're reviewing a license amendment and it has some information in it related to Flex. Maybe you need to get up to speed about, this wasn't in the history books. So what is Flex? How did it come about? It's beyond design basis. How does it relate to the regulatory framework? Imagine if you had, all of that information already in an AI large language model, and you could, use the large language model to get up to speed quickly, and you have access to the right information for the right time and the right task. You're able to interrogate that information in a variety of different formats. Maybe you don't need a formal training presentation. Maybe you want, a podcast or a interactive where you can ask questions and get answers, or maybe you want a knowledge assessment so it can ask questions and talk to you and then figure out where your gaps are and provide you with the information to fill those gaps. So I think in terms of the NRC will have a lot of new staff coming in, and those staff want to get up to speed, want to be able to understand, find precedent, and contribute quickly in their roles. And I think AI is a huge enabler and empowering tool in that capacity. Another application, if you'll go to the next slide, is thinking about how we can leverage AI for smarter, more efficient regulatory reviews. I picked I heard Vic mention using AI to support extended power uprate reviews in the session just before preceding this, but the example I picked here is subsequent license renewal. So consider the situation where, subsequent license renewal, a lot of the scope, a lot of the content is largely very similar in nature to what a plant may already have submitted for their initial license review application. What if we were using AI to do the acceptance reviews and say, does this application contain all the relevant information, relevant sections, and the type of information that I would expect to see in an application? Where are differences and gaps where I should spend more time or need to look closer? And then once we get into the license review, AI could be supportive in saying, which of this information has already been seen, already been reviewed, already been found to be acceptable, which information complies with the expectations in the GAL and the GAL SLR, and simply confirms commitment to apply the aging management plans as expected. And where are there deltas where putting more time and resources into the review is warranted? So I think there's huge potential for not replacing the important role of the NRC as the safety reviewer and regulator, but in supplementing and helping to focus the reviews. Let's see. I'll give an example. I've heard from industry folks that they have cut down the time it takes to produce some of these applications by more than 90%. And I said, well, can you give me an example, or can you give me some more detail on what AI is doing for you in that capacity? Like, is it, obviously we don't want AI generating the data that goes into these applications. And the answer was no, absolutely not. The engineering work, the data, is information they're providing to the model, and then the model is simply, populating all the connective tissue, the writing that engineers are not that great at. It can do a lot of that writing for you, and then you can spend your time on the engineering work and the validation of the application, as opposed to transforming input into different formats and doing the writing of the connective tissue of the application. So we see huge potential for AI going forward, and if you'll go to my last slide, I would like to convey that, of course, the industry is committed to responsible use of AI. We think it will be transformative to the industry, and many of the near-term or medium-term applications of AI, especially large language models, are currently not things that would require NRC review and approval, but we think it's important that we maintain consistent and transparent communication and share lessons learned as we go through these early applications, so that when we get to the point where there's applications that do require NRC review and approval, we've built that framework together and that understanding together. And so I heard a quote recently that said the gap between those that know how to use AI and those that do not know how will never be smaller than it is right now. And so I'm excited for us to jump into this opportunity and learn together as the industry and the regulator, and share those lessons learned and early learnings as we apply AI, so that we're in a position to have strong understanding, so that all of those challenges I talked about on the first slide in terms of responsible, ethical, high quality uses of AI, that we've built that framework to succeed going forward.
Well, good afternoon, everybody, and thanks for coming. And I'd certainly like to thank the NRC, especially Basha and Taylor, who's been herding us cats for the last couple of months to make sure everything comes in on time and on schedule. My name is Tom Grunwald. I'm with a company called Blue Wave AI Labs, and we were founded in 2016, as we like to say, when neither AI nor nuclear were cool. That gave us the time, though, to really build some deep expertise in AI. We've got about 22 engineers who approach every problem we solve as an engineer, but they use AI. So AI to us is a tool. It's not an end. It's a means. So you might ask yourself, why AI? AI isn't meant to supplant all the things we do today. For instance, when you run a reactor, you run a unit, you have a core simulator, and that core simulator is great. However, there are cases in the BWR space where the core simulator can't quite predict certain things that are necessary to run the reactor efficiently. One of those is moisture carryover, and it turns out that AI is able to interrogate the data and predict moisture carryover and several other things. And so that's the practical approach that we've used over the past several years to employ AI in the nuclear current fleet to try to save money and try to make things more efficiently. In fact, in the last 4 years, we've saved our customers $207 million. So when Basha says, what's the value of data? When you use it to increase efficiency, that then demonstrates the value. So next slide, please. So now, about 4 years ago, we were counseled by some folks actually in Europe to start interacting with our NRC folks here, and we met with Luis Benacourt and his team, And he gave us this really nice graph that kind of tells you where you need to start worrying about getting things under the licensing area and where you don't. Now, our position is we try to do augmented intelligence. We don't do anything for the engineer. We try to give the engineer information to make good decisions. And so that puts us, at least with what we do, firmly in the lower left. On the right-hand side, you've got automation. And I personally believe we're a long way off from autonomous operations because we're maybe just not mature enough as an industry to do that. It may happen someday, but probably not right away. The other thing that we do when we approach a problem is we look for discrete solutions, meaning we don't try to boil the entire ocean. We try to look for a problem that's affecting a particular utility, solve that problem, because that allows us to bound the problem, understand what data we really need, and also allows the utility to value what we do as opposed to something that maybe affects their entire company. The next point is defense in depth. We do a lot of testing. We make sure that everything is applied, again, with a human in the loop to make sure that the AI doesn't do anything it's not supposed to do. And then finally, we work within existing systems. For instance, in BWRs, we work within the reload planning team to give them visibility that they wouldn't ordinarily have, and that allows them to both save fuel and diagnose problems in cycle. So that's sort of the way we have approached using AI in the nuclear industry. Bounded problems, a lot of safety, and human in the loop at all times. It's also good to kind of explore how much data there really is, because that's one of the reasons that you use AI. In some cases, there's just too much data for one human or a lot of humans to figure out. It turns out in one daily operation, excuse me, of a BWR, there are 30,000 variables that you could pick from. That's a lot of information to sort through, but the artificial intelligence, machine learning techniques can actually figure that out for you. Which of the 30,000 really make a lot of sense in terms of giving you predictive power. When it comes to the other area of documents and documentation, it turns out that each unit in the United States spends 174,000 staff hours per year per unit on documentation. That's about 84 staff per year just doing documentation. If you multiply it out and you multiply a typical salary times 93 units times 84 headcount, you get a really big number. And if you can save even 5 or 10% of that using large language models, you're going to make an impact on the industry. Next item. So in terms of our application of large language models, we picked a bounded problem called 5059. 5059 is a screening case where if you're going to make a change to the plant, you have to go through a process of evaluating whether it affects your licensing base or not. And so I won't go through all the information there, but there are, for us to do a 5059 project, we have to incorporate a lot of public sources, a lot of NRC sources, and finally, the licensing basis from a particular plant. Next slide, please. This just is a quick look at the process. You start with a question, like I want to know whether using a new fuel is going to impact my licensing basis. Then you are going to search for all the relevant documents, both reference documents and historical 5059s that might have been put in place for other fuel things. Then after you do the reference search, you're going to use that reference search to actually write up the 5059 case and decide whether you're actually going to require a licensing change or not. Next slide, please. This is just a quick look at the way the search looks. You start off on the left-hand side with a question. The system then generates its own set of of reference words, and then the engineer can also either reject some of those or put their own in. And then that's used by the system to find the relevant document right down to the paragraph that actually made that search relevant. That then can be used to evaluate whether the change affects the licensing basis or not. So that's just a quick bounded case of using LLMs in a particular process. But the issue really is that the research takes anywhere from 3 to 4 days to do. So this particular type of LLM is kind of called finding a needle in a haystack. The Adams database itself has millions of pages of documents that a junior person would have a very tough time sorting through to find the right reference. Next. Okay, so that really wraps up what I had to say. I wanted to basically say a few things. Data can be turned into real value if you use it to solve bounded problems that utilities actually have. And finally, large language models are really coming into their own, helping folks to get a lot more efficient. And also, as Kelly said, help the knowledge transfer to the younger generation who needs to understand how to find the information they need, and they need to grow in the industry. Thanks very much.
Okay. Last presentation of the panel here. I want to thank the NRC for inviting us all to be here. Really enjoyed the discussion or the presentation so far, and I'd like to share a little bit with you today around what Westinghouse is doing to industrialize nuclear AI. And I think the messages that you'll hear in this are very consistent with the messages that have already been given around data and compliance and AI and its use cases as well. So Westinghouse is industrializing nuclear AI through our nuclear-specific artificial intelligence system called Hive, and that also includes our nuclear-specific large language model or generative AI model, Bertha. Now, I've used the word nuclear and nuclear-specific a whole bunch of times already, and that was for a particular purpose. And this slide really conveys some of the critical characteristics of AI needed to deploy and apply and generate value in this industry that you have to account for. Some of these are non-negotiable, starting with the compliance. There's no less than 5 areas of compliance that you have to consider, everywhere from data security, data privacy compliance, export control compliance. That's a really tough one in this industry. Global AI. AI is a regulated technology now, and we have to comply with global regulations around that. And as obvious, nuclear regulatory compliance as well. The other thing you have to consider is the data. Without the data, AI can do nothing. Everything centers around that data. So you have to focus on the data, whether it be maintaining correct ownership and access to that data, which is critical, generating and deriving key knowledge bases in specific domains so that you can leverage that data to make decisions and enable users and customers, maintaining traceability of that data. Where did the information come from? Where is it going? What is the source of truth from that? And then being able to integrate it with all of the disparate systems that we have in this industry and with our customers, and then scale that appropriately so you can start generating significant value streams. But it has to be said that our customers and this industry expect us to integrate quality and levels of trust in AI and applying it. That's, paramount. And so with respect to quality, I just want to mention that, it starts with areas like accuracy of the results. Now, whether it's generative AI and accuracy of language or text that's created, or whether it's predictive AI, or whether it's machine vision or classification, you have to generate accuracy that's consistent with the application that you're using it for. The results of the AI have to be pertinent to the activity at hand. If they're not, it's not usable. It needs to be actionable as well. If it just tells me something I already know and it's not really applicable to what I'm doing, what value did it actually give me? And in fact, it could be a form of waste when you consider like Lean Six Sigma. So we also have to make sure that we minimize the possibility, if we're using generative AI, minimize the possibility of hallucinations or minimize the probability of errors if we're creating predictive models. Now, you'll never have zero errors and you'll never have zero hallucinations, but you do have to design and innovate in mechanisms and ways to minimize the probability of that, and then put barriers in place to account for the probability that it's going to happen. And then fundamentally, you have to integrate the right amount of expertise into what you're designing. So that's that knowledge, that's that human experience and expertise that has to be part of a quality AI system or application. And then fundamentally, if people are going to use it and you're going to get value out of it, you have to have trust. And it starts with things like explainability, and I know technically there are 57 different dimensions of explainability and research on how to do that, but it starts with simple things like always having a reference to the context of data that you're deriving something from, right, or that you're creating a prediction from. Clear context, and then that goes back to that traceability as well. You want results that are unbiased, obviously, and incorruptible. So what do I mean by incorruptible? In generative AI space, if I assert something that's false, I would expect my model to tell me, no, that is incorrect, and here's why it's incorrect, and oh, by the way, here's that traceable reference to dig further of the basis for why that's incorrect. So you want to not be able to convince the AI to go along with something that isn't true. It has to be willing to push back on you. And then obviously, and we've talked a lot about already, levels of autonomy, right? And so right now, we ensure that we have human in the middle, right? So technically, we could go to full autonomy in some spaces, but ethically, we don't, right? So we keep the human in the middle. The human is accountable for the results and the decisions made with those results. And then for things like quantitative predictions and models like that, where we can quantify the results in something more than just human language, we have to use the principles of verification, validation, uncertainty quantification, and credibility assessment so that we can quantify the characteristic behavior of these models in their context of use so that we know that we can trust them to do their job as we ask them to. So these are those critical characteristics that have to be embedded in nuclear-specific AI. Next slide. Here's just an example of a few more use cases, and the use cases for AI in this industry are myriad. They range from all forms of traditional AI, like predictive models, to generative AI, as I've been mentioning. On the left there is an example of, well, let me back up for a minute. Almost every use case of AI is about enabling humans to do more, right? To be more productive, to be more effective, to create higher quality, to be safer, right? Almost every application falls into one or more of those categories. So, and you'll see that in these examples as here, whether it's helping a person, a human visual inspector, to catch defects, in this case, fuel debris nozzles, whether it be looking for corrosion, wear in fuel, when we were developing applications for that. We talked about accelerating the creation of documents. Licensing documents, maybe, for Evinci is an area that we're developing AI solutions for, whether it be outlining large regulatory documents, helping create draft content of those. Maybe it's comparing those documents and reconciling them against other documents. Maybe it's making a new generation of a document conform to a particular standard or conform to a guideline. Maybe it's looking for weaknesses in a document or strengths in a document. So there's many applications there, and it's really about making that person more productive and more capable. When you make people more productive, they get to spend more of their time on value-added activities, thinking things that humans are good at, right? Not doing the things that are tedious and making sure that I've found the right piece of information and my grammar is correct, for instance. Predictive models, we're working on predictive models. An example is critical heat flux calculations for operation, that gives us higher accuracy to what our safety limits are than traditional methods. So increasing the accuracy, increasing safety because we know our margins better. And then one thing that AI is really good at is accelerating learning, accelerating competency development in your workforce, bringing people on faster, becoming a mentor for those people, et cetera. So just a few more examples, and we could go on for hours and hours of all the variations of examples. But hopefully you'll see some similar patterns across the board. Next slide. I want to change direction slightly and talk about what does generative AI change in terms of a transformation of how humans interact with this unstructured data that we're talking about? This unstructured data being our body of documented, written knowledge, no matter when it was written, and we're still generating documents today. Whether you're talking about huge public databases, such as the NRC Adams database and all of the knowledge contained within that, or very large proprietary databases, OEM databases, customer databases, all of that is the knowledge that we can work with. But AI really changes the human data relationship. It's permanently changed that now, even at this point in time, and it's only going to accelerate from here. So I can now talk to my data and my data can talk back to me. That's profound, and I want to show you some examples to think along those lines of what is it like to talk to your data. And that's what this slide really represents, is a lot of people start off with something called, intelligent search, right? Find the answer to my question. What's the diameter of this aspect of this turbine blade or impeller or something like that? And get the answer quickly from a vast body of knowledge where you might not really know how to search on that. But think a higher level than simple intelligent search, which can be very effective and very powerful. Think on the terms of knowledge management. So I've got an example question here. Does a main steam line break transient directly cause reduction in the core shutdown margin, or is there an intermediate factor at play? Does anybody know the question? Answer to that? Some of you do, you just won't admit it. There actually is an intermediate factor at play. I won't tell you, you have to go look it up. But what keywords would you search on to answer that if you're not an expert in transient analysis or been trained as a senior reactor operator? Right? That's the kind of question you can ask of your data and get an immediate answer of exactly what that is, why, what's the basis of it, and here's the reference for where you got that information from. It's also about generating insight. That means what you're looking for, you're deriving knowledge or intelligence that might not be directly documented. It's a synthesis, it's a combination of multiple pieces of knowledge and data that are put together to generate new insight. So talk to your data to generate insight. It could be as simple as, what were the NRC's questions, or how were the NRC's questions addressed about topic blah, 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 right? And so it's going to interpret what the RAIs were, what our responses were to it, and it's going to form a basis of how did we address this particular topic, right? What potential gaps may there be in an analysis, right? Looking for those defects. So you can imagine the value of that just accelerates me to focusing on what may be important. What downstream effects might there be, might cladding creep have on fuel models? That can be a very technical, complex, multi-physics set of events that interact with each other that can easily be explained if you connect the right AI models that are capable of interacting with your right proprietary knowledge of what those phenomena are and how they work. Compliance, an example, I'm a reviewer trying to challenge the robustness of the TCD. It understands that's the thermal conductivity degradation model in this case. What questions should I ask? So I'm going to call Baja out in her quote on, the value of data is only as good as the question we asked it. Well, first of all, I don't know what questions I'm going to ask of my data in the future. So the data is the one thing that should always be and you can always start with. But our data can actually tell us what questions to ask of it or ask questions of itself as soon as we start giving it the tools to do that. So it's even beyond that. So the value is nearly infinite on the data that we collect. Competency development. Here's an example of, I tell it, follow this guideline as a standard, the NRCgov 1021, write 3, level 2, which is very specific to that reg guide, multiple choice examination questions around fission gas release. So it's going to go to my technical knowledge about fission gas release and construct questions to help train me in the form of a standard that I provided it to generate the questions around. I could also tell it to become, I could tell my data to become an application. So I could ask a simple question, become a quiz bot asking me these level 2 questions about whatever topic. It remembers the standard I told it to do it, and now it's going to throw itself into an infinite loop, ask me questions. If I get them wrong, it'll tell me why and give me another chance, or generate a new question for me and keep going until I say stop. I didn't do any programming, but now between the AI and my knowledge, it's become an actual computer application that I just described to it, what's your function, what do you do, and it does it. So that's a different way of interacting with your data. I can ask it to become my mentor, guide me. And so what it does will be entirely dependent on how I interact with it and where I want to go and how deep I want to go in any particular topic. And then finally, at a higher level even yet of sophistication is around design. Right? So I can ask it to suggest a compositional alloy, a new alloy to create for an advanced fuel cladding material. And it'll take my proprietary information, materials data, knowledge, combine that together and suggest maybe a set of alloys to develop and experiment with. That could greatly reduce the amount of time it takes for me to develop new cladding alloys, which traditionally can be 15 to 25 years for that development. I could then take it a step further and say, okay, now that you've proposed this new alloy and in the basis for it, model, data, how would this new alloy creep compared to our existing optimized Zerlo cladding? And it will go find the creep equations from your either public or proprietary data, depending on which equations you're using, right? And perform the calculations, come back and say, I had estimated this new alloy to have these differences. I've calculated the effect of those differences. Here's a table of the differences in creep behavior between this new proposed alloy and optimized Zerlo. And then I can tell it to do detailed calculations for me, for instance, if I wanted to say, now calculate cladding creep over particular temperature range. And oh, by the way, don't use the normal creep equations, adjust the radiation component by 8%. Show me what the answer is. So, and you can go on, but I hopefully can have inspired you. This is what we really mean by transforming knowledge-based workflow and allowing the humans to really focus on those value-added activities and interacting with your data in ways that you might not think of when you first approach it. Okay, and then next slide, I think this will be my last one. Final words of wisdom or recommendation is have a very strong artificial intelligence governance program. Whether you're at the NRC, whether you're at a private company, wherever you are. And this is just an example of what Westinghouse has put into place for our artificial intelligence governance. It starts with our AI governance office, which is an office, a group of people that have the roles and responsibility of harmonizing all of the global AI compliance obligations across the company. They also own our AI policies. We have adopted the NIST AI Risk Management Framework as our starting point for evaluating and managing our AI risk. And AI risk can be enterprise-level risk. Don't doubt that for one moment. We have a policy that we created early on the responsible use and ethical use of artificial intelligence. We have a data ethics committee that meets and reviews any new applications of AI, whether we are deploying AI or providing AI. And so deploying is when you buy pieces off the shelf and deploy them. Providing them is when you innovate it and build it yourself and deploy it from there. And then we also have identified a responsible AI officer at Westinghouse, which is the first point of contact with anyone external and regulations to be able to answer any questions about any AI application that we have. So with that, I'll give it to the last slide, and hopefully you were able to use a few of the concepts around what it really means to industrialize AI for the nuclear industry and the critical characteristics of that, primarily focused around compliance, which is a non-negotiable quality and trust. And if you have any other questions, we'd love to talk to you in a lot more detail around AI. That QR code there will get you to us. So thank you.
Well, thank you so much. Those are some great presentations, and we have a lot of questions that have come in. But before we start, it was interesting. I think the theme that we saw a lot across was knowledge management, right? How is that kind of a first use case? And what's interesting is at NRC, we also did some work on a research project to really help our inspectors have some knowledge management opportunities before they go on an inspection. And I know Nick Buggs is here in the front, who helped lead that with the rest of us, with our research group. And we really did find, it was just a research portion. We didn't put it into production, but it did help us find where we were finding success and where we were finding maybe we needed to do a little more work to ask the right questions. And so I think for us, that was really interesting. I wanted to add one thing. It was interesting, when I was preparing my notes for my opening remarks, I, like all of us now, went to ChatGPT and I said, give me some data quotes so I can kind of put this in here. And it provided them to me. But when I looked at them, I thought, it attributed those quotes to certain people, and I'm thinking, is that right? So then I asked it to fact check it for me. The fact check showed me that it did not have the right names associated with those quotes, okay? So I was glad I did the fact check, number one. But number two, we're still in those early stages. We do need to make sure we take that opportunity to really understand that sometimes it doesn't always have it right. So you heard, I think, almost everybody say human in the loop, human in the loop. I see Louise Betancourt there, first person that said human in the loop to me. So it's important that that is still a strong part, that we're not autonomous, that we just let it go, where there is a role for that. So as we move forward, we have to change what that role means to each of us. Each of us has a different way we're going to look at that, from whether as a regulator or someone out in the industry. It's going to be a different way that we approach how that human actually has that role to play. So I just wanted to wind that up, but thought I would share my little insights on using ChatGPT. So thank you very much, ChatGPT. Real quick, there was a housekeeping. This is being recorded. Let me see what else they told me I was supposed to say. Here we go. And that the slides will be made available. Okay. Covered it. And they said, please, this is interactive, so get the audience engaged. So that's going to try my best, but we know it's through the questions. All right. So the first question we had was sort of open. It says, is AI used in the regulatory review and assessment work? Did you set up some rules for using AI at the NRC? So I'll start with that. We are still in the discovery phases. We do have some AI built into some of our smaller projects, just like Jason and Matt talked about with the LERs. We are able to use something called document intelligence, and it's able to strip information out of PDFs and put it into our system. They did a lot of work. I know Jason worked a lot to validate that information was coming in correctly, but we're still in the sort of early stages before we're really feeling comfortable that we have a strong understanding, because trust came up as well. If we move too fast and we find that we're not putting out the right type of information and we're not getting the right results, it might take us back further. So we're ensuring as we go through and testing our AI applications that we're building are actually giving us the results we expect. I don't know if there's anything else y'all want to add to that. You guys are good? No, you're good. Okay. Let me see. There was one here for Kelly. Guess what? Where was that one? Oh, here. All right, Kelly. What do you understand by responsible use of AI? What is your definition of that?
I think Scott did a pretty good job in his slides of addressing the factors that we would want to include in responsible use of AI. So, all of the legal and data and export control, but I think more importantly for us as engineers, the quality and trust on the back end.
Great. Let's see. I thought this one was interesting. Someone had asked for the NRC staff about, whoops, hold on. I lost it, uh-oh. You would think I would be better with this than I am. Okay. This one was saying they're a layperson in this area, but how do we have confidence that the AI system prompts we put in are staying within our tenant? And so it's interesting. As we talk about AI, we are often, I think all of us, working within our own tenants. At NRC, the testing that we're doing is within our firewall. So we're taking the models, we're bringing them in so we have control over that. We know it's not going outside of our firewall to actually do some interaction. So we bring the model in. And I think I would assume that that's what everyone else is doing as well, is ensuring that they're not just opening it up to the full breadth of the internet and what's out there as availability. But I would say, is that how everyone else would approach it as well?
Yeah, I mean, the aspects of data security are paramount in that. And whatever your infrastructure design is in assuring that data is not accessible or seen by folks that are not allowed to see that, and it maintains, critical security characteristics wherever it resides, not only where it stays at rest, but where it is processed at. And also, that includes, if you are training models, the data effectively gets incorporated into those models. There's ways to apply AI where you don't need to put your data inside the model, make it become part of the model through training and weights, and there are other cases where you do. So you have to take that into consideration as well. But you absolutely have to comply with not exposing data to any actors who are not allowed to see that.
Great. And this one's for you, Scott. It appears Westinghouse has invested significantly in setting up an AI governance framework. How do you think the federal government, NRC, should mimic what you've done, or what lessons learned would benefit federal applications?
Well, we're certainly very happy to share the details of the type of governance that we've set up. We had to do it by necessity because we want to be out there developing value-added applications both for our customers and ourselves. And even as regulations evolve, including, the EU AI Act wasn't in place when we started, but we had anticipations of what was coming. So we're very happy to collaborate with anyone and share our knowledge of that and how we've solved some of those problems, just as some of what we shared today shows kind of the outline of how we approach it.
Thanks.
So, if I could add on both those last two questions, there are industry groups like the AI Innovation Task Force, EPRI has collaborative projects, and those two questions of governance and sharing lessons learned are certainly, as well as data security, and companies are coming to different conclusions about whether that means on-prem or in government cloud or but sharing the lessons learned and sharing the challenges are certainly key topics in those industry groups, and so we're all learning together, I would say.
And I would agree, governance is a key piece. Also for the NRC, we're ensuring that we have that stood up before we move forward on any, really any big AI efforts that we're going to be installing as well as within our own, government availability as well. All right. The next one, all right, Jason. He's like, oh, it's me. Let's see. People are asking, what are some challenges that NRC has faced with data consolidation efforts?
Some of the initial challenges that we had is we had a lot of different systems that we had to tie together that didn't necessarily have a primary key type field. So we had 14 different systems that were all using different ways of referencing back to the same thing, like the site, for instance. So working through that was an initial challenge. I think some of what we have recently is developing a process that we can quickly identify data issues that exist in some of our tracking systems, like RPS, and having an effective way to work with data stewards, identify a point of contact that is responsible for that data, and then making sure that the issues that we've identified get resolved in a timely manner, because sometimes you don't have a clear idea of who is responsible for that data or where it was. Sometimes it's legacy data that we end up having to go fix ourselves. So I think the primary challenge that we've seen is, yes, inconsistency across systems, tying things together from those multiple systems and creating a consistent crosswalk between those systems, establishing some kind of key that we can use to define our views, and then kind of the human element of making sure that everyone's invested in maintaining data quality throughout the organization and having a more rigorous process to address those issues.
I love that you mentioned data quality, so thank you for that. All right, and Matt, a question for you is, what are some of the current near-term activities that the Office of Research is doing to help us kind of move forward internally in our AI journey?
Yeah, sure. So research has been supporting NRC AI efforts since the very beginning. This isn't new territory for us at all. Going back several years to 2021, we've been supporting AI initiatives with our Future Focused Research Program. That's one example. We've had several projects that have been launched that way. And also, more recently, we've been pursuing direct research work requests with the client offices, running a project right now for knowledge discovery, like we've been talking now for, that's going to hopefully help the advanced reactors folks. Beyond that, though, the NRC is developing a enterprise-wide AI strategy that's going to take us forward. That's going to include the research stuff, the internal stuff, and the external things as well. And we're also investing in some foundational tools that are going to support our high-value use cases internally.
Great. And here's one that's, thanks for that, Matt. Here's one for everybody. It's sort of interesting. So it's a long question, but let me go ahead and read the whole thing. Using AI to help make decisions, writing licensee applications, et cetera, can be a huge help in the short term to make tasks easier or more productive. But there's a lot of value in people doing activities from scratch, repeatedly reading entire documents and applying them to help develop a mastery of a subject area. As the use of AI expands and deepens to assist in that short term, has there been thought given to long-term harms it may pose and the loss of real human expertise in those areas? I don't know who wants to jump on that one first, but I know that's a question we get quite a bit.
Maybe I'll speak from personal experience, which is I have a 20-year-old college student at MIT, and I don't think he's read any book from scratch in his whole life. So fundamentally, I think the new generation just expects to be able to find the information that they need to do the task they need to do, and I think AI is an enabler of that.
All right, so I'll take a crack at it, a little bit different angle. So I'm an engineer. I'm a nuclear engineer by training. I've spent 30 years in this industry, And I remember my peers around me when I was in college, engineers typically follow up, memorize it or derive it. And you have two different styles. And I'm always a derive it from scratch kind of person, which sometimes takes me a little bit more time than if I would have pulled it out from memorization. So I think access to the right amount of knowledge and information in the right context allows me to go straight back to the point I need to start deriving things to get to a decision. So I find that this context, this paradigm helps me significantly.
Great. Tom?
Yeah, I have a similar view on that. I think that AI is much like if you go back 20 or 30 years and everybody typed their own papers, and then we had Microsoft Word and we had Excel, and what that saved us from doing was a lot of repetitive drudgery, and we could spend our time on maybe more intellectually challenging and maybe more important tasks. And I think AI will turn out to be something like that. To me, the downside is that people believe everything that the agent tells them. Yeah. And so you have to still maintain critical thinking skills. But I think it saves time. In other words, would I rather have a young engineer spending a week searching through the Adams database, or would I rather have the person find the information really quickly and then write a very cogent report on what they found? So that's kind of how I look at it.
Yeah, or intelligently go to their peer and ask a more intelligent question to say, hey, I found this, help me understand it better, or I have a question about this, why can't we do it this way?
Right.
So it really does help in that higher level, value-added discussions, even with other humans.
Thanks. Jason?
Sure. From the NRC's perspective, I have a few thoughts there. It's like, from my perspective, having suffered through a lot of the processes, I really want something that'll make it more efficient and pass that on to the next generation so they don't have to suffer through that.
Yeah.
But on the other hand, I also do want us to have a very robust qualification program in these areas that would at least get them through going through some of that process themselves so that they have that perspective and understanding of what it really means if they're using some of those next generation tools. So that's my perspective.
And just a final thought here. I think the need for experts going into the future is still going to be there for sure. Somebody has got to be that human in the loop. They've got to check what the AI is providing. We may not need as many of them going forward. We're going to have to sort that out. But clearly, there's still going to be a need for humans with expertise and likely a high level in some cases.
Thanks. I thought that was a good question. Thanks for everyone's answers. I think it's going to be something that's going to be continued to bat around a little bit. But again, it's like any other tool that we've used, calculator, Word, things of that nature. It does help us move us forward and get us to the critical thinking that needs to happen. All right, this one was sent to Scott, and anybody can feel like they can jump in. How do you make sure that your AI results are qualified or verified under NQA-1 quality assurance regime?
So that's a really good question, and that is one of the areas that we are focusing on, being consistent with our NQA-1 procedures and policies. And I think it's on a case-by-case basis, right? So when we get down to those specific quantifiable applications where we have to validate the performance of the results, and we have to adhere to those same standards. And so that's something that we're on the forefront of doing, because it's easy for quantitative predictive models and things like that, right? So when we get to generating human language, it is still, again, coming back to this human in the middle. There's part of our procedures and policy at Westinghouse, I'll mention, is that we do not allow AI to create a technical document or technical analysis. And in our quality procedures, we require both authors and verifiers of any analysis. and the author is accountable for the quality of the analysis. The verifier is not. You can't verify in quality. So if you allow the AI to become the author effectively, then you as the author become the verifier, and the AI cannot be accountable for the quality. So that's instilled in our policies and procedures to prevent that. Now, I say we're on the cutting edge of this is because all of our engineering policies and procedures didn't incorporate all of the various aspects of AI that would be coming along so rapidly. So we're in the process of reviewing and updating those procedures to ensure that we're adherent. So.
Thanks. Anyone else? Okay. Did you have something, Tom?
Yeah, I think that's a great point. We had a similar case. We developed, well, there was a company that was doing commercial grade dedication, and those documents are complex and intricate, and they were spending an inordinate amount of time reviewing those things. And basically, we developed a AI that went through and reviewed it and found errors and cross-referenced everything, but the author was still accountable. It was just a tool for the author to not have to grind through this thing mega ohms or ohms, et cetera, et cetera.
And I think that that's really when we start looking long-term, when people ask about, they're going to be submitting, whether it's applications or, any type of, we expect that whatever it's signed off when it gets to us, right? And then we're going to take it from there.
Yeah. Somebody gave me a great analogy to this too.
Yeah.
In terms of, there's the aids that you have, all types of systems and computer apps, et cetera, that help you. But if you take the case of an airline pilot, they have automatic pilot, but they still have to be able to fly the airplane.
Okay. That's a great analogy. I like that. Great.
Thanks to Jonathan,
All right. So I think we're mostly through some of these questions. I would say if anybody has any last words that they want to share, otherwise I'll go into closing remarks. Anybody have anything else that they wanted to share? Uh-oh, Jason's turning it on.
I just wanted to thank the people who responded to the survey results, because that is going to help inform my, next weeks of work out there. Thank you very much.
Did you put the polls up? I don't even know. Oh, is there a poll that we're supposed to put up? That's on me, I think, to say poll. Thanks. Is that the one? Oh, there it is. Oh.
Yeah, this one's very helpful. We're actually addressing the bottom three as we speak on the high-value datasets page on NRC.gov, and the top one, we will definitely be putting that into priority. Thank you.
Thanks for that. Awesome. Poll number 2. Poll number 2. Did you already do the poll number 2? It's like a drum roll. I don't know. What is it? Oh, okay. Go ahead and answer poll number 2. Okay, and while we're doing that, we'll get that, but thanks for bringing that up, Jason. All right, so I'm going to go ahead with, while we're watching this come up here, just give you a couple of closing remarks. So I really, first off, I want to thank everybody. This has been a great conversation. I think there's a lot more conversation to come. I know we're really looking to continue to partner with our external stakeholders. I know that Kelly and I have talked from NEI that we're going to start trying to really make sure we have regular discussions to ensure that we are providing data in a way that is needed and best used with our public atoms. So, throughout the session, we explored how AI and data-driven technologies are transforming and enhancing our data decision-making, which is really the key of what we want to get to. At the same time, we acknowledge the critical responsibility that comes with this progress, ensuring that innovation does not come at the expense of safety, security, and ethical considerations. Some of the key takeaways: right now, AI's potential is limitless. We're going to continue to make sure that we have governance, transparency, and accountability. Data is a powerful enabler, right? We've talked about that quite a bit here, but it's the quality that's really going to be important that we have, as Jason talked, to make sure that we have the right data that we need. Regulatory frameworks must evolve, ensuring that AI-driven advancements enhance safety rather than introduce new risks. And that's going to be a key piece, I think, that everybody has the concern of, and I know a lot of these questions, we're getting to that. And collaboration is essential across industries, across agencies. It's important that we continue to share and really see data democratization at work. And we're committed to being a part of that, and we really look forward to continue to work on our outreach. As we move forward, we want to ask the right questions, challenge assumptions, and develop AI solutions that are both innovative and responsible. All right. I'm going to leave you with, this is one of the quotes that was wrong, so I went and got the correct quote. I don't know if anybody knows Fei Li, she's a Stanford. It was interesting what they had come up with, but really, I love what she said. The tools and technologies we've developed are really the first drops in the water of a vast ocean of what AI can do. And so I hope next year when we talk, I can only imagine what we're going to be talking about in a year. I know last year when we had a presentation, it was really just, really kind of thinking it through. Now we're starting to make progress. I'm really excited to see where we are in a year. So let's harness AI and really get to the greater good. So I want to thank Jason, Matt, Kelly, Scott, and Tom so much for joining us. And we appreciate all of you. Did we get the last poll? I didn't see what the numbers were, but hopefully it was for data analysis. Okay, I'm not shocked about that. Really look forward to continuing. If you have any questions, you can reach out to any of us. We continue to look to collaborate moving forward. And again, I want to give a shout out to Taylor and thank you to Isaac too for joining and keeping us on task. And we're going to let you get out of here a couple minutes early because I think 5 o'clock is the witching hour here. So thanks you again, and we'll be around if anybody has any questions.